This one is a basic code generation task. Now, these are very powerful models. Probably need to update this particular test, but I just want to check it just to see how it performs. I'm looking for a couple of things here. Usually I look for the name of the function. So the name of the function here, multiply and subtract, and then 10. We see that it gives us the arguments, it explains that. Also, it generates comment, which I really like, which is something I'm seeing more and more with these models, that they're getting really, really good at generating code and providing context and providing comments and explaining the arguments and so on. So very, very good code generation capability. And they also gave me an example usage, and they also gave me an explanation. Other models, they give you the example usage here, and they don't give you an explanation. So it really depends on the type of training and the type of use case that you want to use this on. So for this one, I believe the only one that has gotten this one right is Llama 3.1 405B. I did a video on this. Do check it out. It's on my YouTube channel. This one is an interesting one. It's like a math puzzle. And I also saw that the other models don't get it right. Like if you try GPT-4o, fails. If you try the Cloud 3.5 Sonnet, fails at this every single time. The issue here is more about the character, I would say, recognition, or ASCII character recognition in this case. But it also like spits out very weird explanations, and it's just confusing the task, right? It doesn't really understand the task. And so in some way, it kind of hallucinates. It really tries to respond. So I'm really curious about this. Most models respond, again, all the models respond with 4, right? And the only model that has responded with 3 from all my tests when I've sampled these models is the Llama 3.1 405 billion parameter model from Meta. So let's test this. And I'm going to test this for the first time. There we go. So this is, again, what I expected. So this is a complete fail, right? So the candle that was blown out first by Peter would be the one that burned the longest before being extinguished. Therefore, it would be the shortest candle now, as it had the most time to burn down. This is incorrect, right? So it would not be 4, it would be 3. But this one would be the answer. Hi, everyone. So we had a very crazy week in the world of AI with all these releases and product launches. And Mistral was also part of the set of announcements that we saw this week. So they announced Large enough. What I wanted to do is go through some details about Mistral Large 2, which is their new generation of their flagship model. There are a few aspects of this particular announcement I found really interesting. So we are going to get into those in this video. Plus, we're also going to test it a bit because it's available in the chat. Basically, what they are pushing for is a very performant and more cost-efficient model, also keeping in mind speed. So there has been a lot of improvements in terms of the inference capacity of these models, so pushing for faster models. So Mistral Large has 128K context windows, so that's what they support on dozens of languages, right? And here are all the languages that it supports. Now, this is an interesting one because with these larger models, what we're noticing is that these companies are trying to have more support for languages. And not only support for languages, but the ability to do, like, for instance, agents or function calling in those languages as well. So it's becoming more broad, so to speak. And I think that's a natural evolution of these larger models. So as we get to like maybe a Mistral Large 3 or a Llama 4, I think we're going to see more and more of that capacity. Right? So the ability to understand more and more languages. So I don't know, maybe we get to like hundreds of languages soon, but also like coding languages, because one of the biggest use cases of these models is coding, right? So in this case, they support 80 plus coding languages. And also like the 4OB language model from Meta, the Llama 3.1, they also have a lot of support for different languages, and they actually scored really good on code generation. So we're going to get to the results in a bit and just kind of compare how these two models perform on all these benchmarks. Again, for efficiency's sake, we want to be able to deploy these models in a single node inference that's desirable, especially for the type of applications that we want to build, like RAG systems in production or agentic workflows. But they also support like long context applications. It's a 123 billion parameter model with large throughput on a single node. Again, they have it on a Mistral research license. So this one only allows usage and modification for research and non-commercial usages. So that's very clear. If for some reason you want to commercialize the usage of this Mistral Large 2, apparently you have to acquire a Mistral commercial license by contacting them. So the first test here is the general purpose. This is general knowledge. Performance, how it performs on the common benchmark would be MMLU. So that's kind of what everyone is using to assess the general knowledge capability of these systems. So Mistral Large 2 achieves 84.0% accuracy. They don't have a drill down of the results here, but I believe if you go to the Llama paper, so this is the Llama paper, you can find that in their report. You can see here, just as a comparison, how Llama 3 405 billion parameter model, how it performs. And you can even see here the Llama 370B, which is also a very powerful model, how it performs. So it's 83, is very close to this 123. For some reason, they didn't include that chart at the top, but I just wanted to make that comparison. Now, keep in mind that it's kind of not fair to do this comparison again because they have their own ways of how they're doing their evaluations. So code and reasoning, this is the performance for code, this is the performance for math. Again, you will see that here is Llama, and obviously Llama is a big model, but you also compared with the 70B. Anyways, you can see that this is the best performance size ratio that they're targeting. And again, they're focusing on these commercial applications, enterprise applications, and it's a bit high as we can see here, but they go through many different benchmarks, and I'm going to go through them now. So do an overview of these. But they mention and they claim that it performs on par with leading models such as GPT-4o, Cloud 3 Opus, Llama 3, 405B on all these code and reasoning tasks. So here is the benchmarks for human eval. These are code generation benchmarks. Where you can see that Mistral Large is right here in orange. Now, this model here, this in gray and this lighter gray here, these two models is the GPT-4o and Cloud 3.5 Sonnet. Anyways, so the focus is Mistral Large 2, and you can see the different gaps. And I think this is a very close gap. Now, the Human Eval Plus probably a bit more challenging. You can see the gap gets a bit bigger, but still, I think because it outperformed 3.5 Sonnet, it's still very outstanding for this size of model. Very interesting, again, Cloud 3.5 Sonnet, how it outperforms. So I think an average of this will make sense to do, but you can see that these models, the Mistral and 405 billion parameter model from Meta, are closing in the gap. So this is just the chart for the multiple E. This is another benchmark, and you can see all the different drill down of how it performs in different programming languages, along with the average. GPT-4o, best model out of all of these, especially in the average as well. But you can also see that they included the Llama 3.1 405 billion parameter model performance, their own internal evaluation, and also the one that was reported in the paper. And apparently here in the bash, there is a bit more performance here from the 405B from Llama 3.1. But overall, GPT-4o kind of overtakes all these models with the exception of Java. Now, this could be the case that this model has access to more Java type of data. I'm not sure about this specifically, so it'd be interesting to do more experiments that compare Java for all of these different models, like Java code generation. Anyways, that's interesting. But at the same time, the gaps, I think, are getting less and less. Now, this one is about math reasoning. So these are the math benchmarks. You can see that this one, again, the one in orange is the model, their Mistral Large 2, how it's performing compared to the more performant models on this particular benchmark. So this is 405B, Llama 3.1. You can see here in the light gray. And on this particular math benchmark, Mistral Large outperforms the 405B, but on this one, GSMAK 405B outperforms Mistral Large. So if you do the average, I think you will see that they're very similar in performance. These ones are interesting as well as the instruction following multi-turn. And this is one is graded by GPT-4o. And the performance is very, very close to GPT-4o and Cloud 3.5 Sonnet. So when we are comparing Mistral Large 2. So this shows this is a very strong model, right? On all the alignment, all the instruction following. Now, something that I mentioned here is that since they're really focused on like business applications, conciseness is really important. So as I've mentioned in the past with my experiments, we have models that generate like very long text, but that long text usually leads to like hallucinations, sometimes gibberish generation. So it's not really ideal to have models generates such a long text unless those use cases really require it. The majority of use cases probably today don't require that. And so they are training these models to produce more concise text. This is what they're showing here, the average generation length. And that doesn't really hurt the performance according to what they're reporting here. So this is what we would like to see, right? That it's more concise, it's straight to the point, because the majority of use cases will in fact benefit from that. Now, something I notice here with the language capabilities, now this is the using the multilingual MMLU, but you can see here the drill down of all the different languages. So the languages they support is a lot more compared to the Llama 3.1 405B. So the Llama 3.1 model, you can see that it supports, I believe it's 1, 2, 3, 4, 5, 6, 7, 8. So 8 languages in total. And this Mistral model supports 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's up to 13 languages. So that's could be a good benefit you can say about Mistral Large 2 compared to this Llama 3.1 405 billion parameter model. So it's still very interesting to see these results. You can see that this model is very performant also on these tasks, but you can see the drill down here how it looks. So this is 405B. Now, something that I read in the Llama paper right here is that although these models or that particular model, that Llama 3.1, was trained on 8 languages, it is possible that these Llama models still are performant on these other languages that were not explicitly mentioned in that model card. And that's what we're seeing here. So there are specific languages, for instance, Chinese wasn't really explicitly mentioned. I believe also Russia is not one of those languages. So we still get good performance from this 4 or 5 billion parameter model, right, compared to Mistral Large 2. So that's really amazing to see. You can tell that this model has very strong multilingual capabilities, and Mistral Large 2 is catching up. This is more about tool use and function calling. So if you're building agents and maybe combining language models with external tools, it's really important to measure this as well. I don't know too much about this particular evaluation that they did, but they're just showing that their one outperforms the other ones. And this could be because of the use cases and tests that they're doing. Anyways, I want to take this model for a spin just to show you some examples and how it's performing. So the first one that I like to do is just a little knowledge task. So I always test these models because they are instruction tuned models. So I like to ask them for very subjective type of tasks, right? So I want to see if they want to opinionate, for instance. So that's something that we see a lot with these models. So I just want to test that. Yeah, you can see most models will respond like this. Like they would say, the best sushi can be subjective as it depends on personal preferences. I'm not providing it sufficient context. And by the way, this is something that they mention in their blog post, that if there's not enough information, that the model doesn't try to guess. It's just going to tell you, well, maybe this is objective. Maybe I don't have enough information. And I think that could be very ideal capability of models to sort of know when to respond like that. The next one I want to test here is a very simple code generation task. So I'm actually going to clear this just so that we don't have any biases coming from the previous responses that were generated. Again, this one is a basic code generation task. Now, these are very powerful models. Probably need to update this particular test, but I just want to check it just to see how it performs. I'm looking for a couple of things here. Usually I look for the name of the function. So the name of the function here, multiply and subtract, and then 10. We see that it gives us the arguments, it explains that. Also, it generates comment, which I really like, which is something I'm seeing more and more with these models, that they're getting really, really good at generating code and providing context and providing comments and explaining the arguments and so on. So very, very good code generation capability. And they also gave me an example usage, and they also gave me an explanation. Other models, they give you the example usage here, and they don't give you an explanation. So it really depends on the type of training and the type of use case that you want to use this on. Now, at least for me, when I asked this, I was expecting more the example usage to be separated, right? Separated here, and just kind of avoid the explanation. But this is something you can tune. You can actually go here and tune it. So this is really why it's important to test these models on these tasks, because the output that you're getting, right, might not be suitable for you. And this is how you determine which is the model that you're going to select for instance, in this case, a code generation task. Now, if you're generating documentation, for instance, right, that would be ideal that I get this separate. So it really depends on the use case. The other test that I have here is this one. What are the last 4 digits of the sum of the first 70 prime numbers? Now, this is a very difficult task. And when I test this one, GPT-4o sometimes does well on this. Sometimes Cloud gets it as well. But for this type of task, you sort of need a code interpreter that will be useful. But I just want to see how it performs, because if it has good long context understanding, right, and it has that math capability, just like what GPT-4o has, then it would give us an interesting answer. So I'm just very curious how it would perform. So yeah, it's doing the first 70 prime numbers. You can see it's listing them. And then it's going to do the calculation. Usually here is where these models actually fail. Okay, now it's doing the addition. And then it says the last four digits of the sum are 3,661. So that's incorrect. It's actually 0,887. The total or the summation would be 10,887, I believe. So this one is incorrect. All right, so I have another easier one here. So this is more sort of like chain of thought testing to see if the model has some understanding or has native support for chain of thought. So I would expect that it kind of lists the steps. So I'm going to remove the break the problem into steps so that it's not biased, but I'm just going to test that really quickly. So it did a few steps here, which is good to see. It doesn't show you like the step 1, step 2, step 3, like the other models, right? So if you've tested the Llama 3.1 405B, it does list out the steps. The Gemma models also list out the steps. And I believe the GPT-4o models also list out the steps. But this one is not listing the steps, but explicitly mentioning the steps. But I can see it's taking the steps, right? It's just doing it in different format. So it says the statement that the odd numbers in this group add up to an even number is incorrect, which is true. The sum is actually an odd number, which it is. That's great to see. Now, one tricky math logic test that has been going around is this one here. And I've done a lot of experimentation about this. You can go to my Twitter and do check that out there. But this one is very interesting because all these models struggle with this. So this one, you can see that the model says 9.1, 9.11 is bigger than 9.9, which is not true, right? And there's a lot of discussion around this. And even Carpati has had some analysis on this as well. I have my own hypothesis about this. I think it has to do with some kind of pattern recognition issues with these models. But obviously, you can always solve this using something like chain of thought. But anyways, I think it's an interesting test. It's something that we will be testing with future models as well to see if it understands. There's a lot of discussion around it. People say it's because maybe these models are trained on a lot of like software type of data, like code type of data, and it's influencing the model because, in that case where you have like software versioning, this will be bigger than this. But still, you can see the mix up because then it goes into numbers and it tries to, create logic behind it, and it tries to give us some reasoning as to why 9.11 is the larger numbers. Anyways, one I want to test here, this is an information extraction task, which is one of the most common ways on how we use language models today in the real world. So when I work with clients, this is an important use case to get right. So generally speaking, I want to test these models whether they can extract information tasks and can follow instructions around those particular tasks. So here are the instructions. I want to extract the model names. If the model names don't exist, return NA. So that's the behavior I want. I'm just going to hit submit here. So it does get NA, which is good. I've also done the other test and it passes as well. So it's really good to see that. And one thing I don't like with these models, sometimes they give you like explanation, right? So in this case, we didn't see the explanation, which means it understands the intent of the task and it gave me what I wanted to see. One interesting claim in the blog post, you can check it out there, is that these models have been trained to not respond when it's not confident enough, and that would reduce hallucination. So I want to really test this on a couple of questions here. The first one I want to do is this one, and I'm very curious. Obviously, this is unsolved, but we'll see what it responds. So I'm afraid I can't solve P versus NP problem for you. This is one of the 7 Millennium Prize problems in mathematics, and it's currently unresolved. So I think this is fine, right? It didn't really hallucinate anything or made up anything. And I have another question here that's more around knowledge and to see if it confuses or makes mistakes on it. So we're testing to see if it's just going to make up stuff because, again, these models tend to want to always respond something. And my AI and my knowledge cutoff is 2021. Not sure if this is entirely true though. That looks like a mistake. If this is the large 2 model, this is probably not true. But again, I'm not too sure about that because they didn't really mention that, I believe. Maybe they have, not too sure, but it doesn't look correct to me. It says, therefore, I can't provide the winner of the, you will need to check the latest sport news, or the response is fine. It's just this one I was a little bit confused about. So are Formula One drivers allowed to teleport themselves after 5 laps? This is a very famous hallucination problem. It says no, Formula One drivers are not allowed to teleport themselves after 5 laps or at any other point during a race. Teleportation is not a technology that exists in the real world, and certainly not within the context. Okay, drivers must physically drive their cars around the track for entire. So in the past, what these models had done is that they say no, it's not allowed, and then they say, teleportation is not something that's currently allowed in Formula One racing and so on. But now it seems that these models kind of are smart and will respond with this, like making a claim that the technology doesn't really exist in the real world. So that's what you want to see, right? So at least this one, I think, is sort of a pass. And one more test I want to do here is this popular one that I've been doing for all of these models as well. So for this one, I believe the only one that has gotten this one right is Llama 3.1 405B. I did a video on this. Do check it out. It's on my YouTube channel. This is one is an interesting one. It's like a math puzzle. And I also saw that the other models don't get it right. Like if you try GPT-4o, fails. If you try the Cloud 3.5 Sonnet, fails at this every single time. The issue here is more about the character, I would say, recognition, or ASCII character recognition in this case. But it also like spits out very weird explanations, and it's just confusing the task, right? It doesn't really understand the task. And so in some way, it kind of hallucinates. It really tries to respond. So I'm really curious about this. Most models respond, again, all the models respond with 4, right? And the only model that has responded with 3 from all my tests when I've sampled these models is the Llama 3.1 405 billion parameter model from Meta. So let's test this. And I'm going to test this for the first time. There we go. So this is, again, what I expected. So this is a complete fail, right? So the candle that was blown out first by Peter would be the one that burned the longest before being extinguished. Therefore, it would be the shortest candle now, as it had the most time to burn down. This is incorrect, right? So it would not be 4, it would be 3. But this one would be the answer. I'll be doing more deeper tests with this model. I have to cut the video because it's getting too long. But I might do a part 2 with this particular model, and also how it compares with the Llama 3.1405B. And what I will do for this test, I'm just going to focusing on their API, how these models compare in terms of performance, in terms of speed, and for a lot of these different tests that I'm running with them as well. Stay tuned for that. I'm going to do a deeper analysis on that. So if you are interested, let me know in the comments what exact tests you would like me to try as well, so that I incorporate them. But besides that, thank you for watching. Please leave a like and subscribe to the channel if you haven't, and I'll see you in the next one.